Example 323 says to find a system has this augmented matrix. Use Gauss-Jordan to find its solution. All right. Now, I could go ahead and divide by 3 to get a 1 here, but that might not be the best thing to do. I can see two other things that would be better. One would be to take this row. Notice all the entries on there are multiples of 3, so it would make sense to divide everything there by 3 just to get smaller numbers. But I think what I want to do first is use this to zero out the rest of this row, and then we'll put that one on top. So I'm using this 3 as my pivot, and I'm going to do row 1 minus row 3, and I'm going to do row 2 minus 2 row 3. So row 3, the one with the pivot, doesn't change. Well, let's see, row 1 minus row 3 gives me 0. 5 minus negative 6 is 11. Negative 1 minus 3 is negative 4. Then 4 minus 0 is 4. Then row 2 minus 2 row 3. So it's going to be 6 minus 6. Then it's going to be negative 1 minus 2 times negative 6. So that's, let's see, negative 1 plus 12 is 11. And then 2 minus 2 times 3. So that's 2 minus 6 is negative 4. And then finally 3 minus 2 times 0 is 3. All right, so notice what we've got here. I'm not even going to finish putting this into Gauss-Jordan, into a reduced row echelon form. The reason is these two equations here, those are two parallel lines. What this says is 11, well, let's say our variables are x, y, and z. This says that 11y minus 4z is 4, and 11y minus 4z is 3. Or in other words, 4 equals 3. So this thing has no solution. So I'm not going to finish this problem out, or rather I'm not going to finish row reducing the matrix because we don't need to. We can see immediately that it has no solution. Now let's look at it on Octave. I'm going to type it in. I tend to use M for my matrix just because, M for matrix. But let's type that in and then see what happens when we row reduce it. See, 3, 5, negative 1, 4, 6, negative 1, 2, 3, 3, negative 6, 3, 0. I love using Octave for this because it's so much faster to type a matrix in here than it is on a calculator. So if I take the reduced row echelon form of this, notice what it gives us there on the bottom. This bottom line says 0 equals 1. That'll always happen if your system has no solution. All right, example 324 says to solve the system with this augmented matrix. So I'm going to use this 2 here as my pivot. First thing I'm going to do is do row 2 minus 2 row 1. So my first row and third row will remain the same. Yeah, I realize, why am I not getting a 1 there to begin with? Well, we can go back and divide by 1 later. Divide by 2 later to get the 1 there. For now, I want to do this to avoid having fractions. So let's see, row 2 minus 2 row 1 is going to give me 0. Let's see, 5 minus 6 gives me negative 1. Negative 2 minus 2 times negative 1 is 0. That's nice. And then I get 10 minus 2 times 7 is negative 4. My bottom row is 0, 1, negative 3, negative 5. Okay, I could go ahead and divide that top row by 2, but I want to wait because I want to leave the fractions for later. Let's see. I think what I want to do now is use this -1 as a pivot. And I'm going to do row 2 plus 3. I'm sorry, not row 2. Row 1 plus 3 row 2. And then row 3 plus 1 row 2. All right, when I do that, let's see. The middle row stays the same, 0, -1, 0, -4. The top row becomes 2, 0, then -1 plus 3 times 0, then 7 plus 3 times -4. So what is that? 7 minus 12 gives me -5. And at the bottom, I'm just adding these 3 rows to the 2 rows together. So let's see, 0 and 0 is 0. -1 and 1 is 0. -3, and then -9. All right. So what next? Let's divide this bottom row by -3. And now there's 2 things left to do. Add that bottom row onto the top row. So row 1 plus row 3. It gives me 2, 0, 0, -2. And then what else? And multiply row 2 times -1. And now I'll do row 1 times 1/2. And that'll give me 1, 0, 0, -1, 0, 1, 0, 4, 0, 0, 1, 3. All right, so that should be the solution to our system. X is 1, or rather x is -1, y is 4, and z is 3. Now let's check that by looking at Octave. I put it in here earlier, and I've already row reduced it, so we get -1, 4, 3. So that's good. All right,